Hello, this is a geological map of northwest Scotland. It shows the details of the ancient rocks that we can now see as we walk across the hills. I've spent many months mapping the outcrops and structures of northwest Scotland. Today, I'd like to show you how we can use the Earth topography to add to our 3D understanding of the field geology. Here's a geological map of northwest Scotland. Over to the west, you can see the generally pink area of Lewisian gneiss basement. Above that is the brownish Torridonian sandstone, and above that is the grey quartzite. On the other side of the fault thrust line is the light-coloured Moine metamorphic belt, and this has moved from east to west across the top of the Lewisian gneisses and Torridonian sandstone and quartzites. You also see that along some areas you see a sort of window into what's below the Moine Thrust. So let's zoom in on northwest Scotland. This white line is the line of roughly the line of the Moine Thrust. So to the west, we've got the ancient foreland, and to the east, we've got the Moine series of metamorphic rocks. And a particular area that I'm interested in is near Ben More, just zooming in there now. Near Loch Assynt. This is a picture of the classic Glencoul thrust. Here it's very clear that the Lewisian gneiss is repeated. And this was explained back in 1890 by invoking this concept of a thrust fault. So this was the first time that these thrust systems had been understood and mapped out in incredible detail. So we've got Lewisian gneiss, Cambrian, the thrust fault, and then Lewisian gneiss again. Of some of the features. This yellow line, this is the Moine Thrust. The black line is some additional thrusts called the Ben More Thrust. If we go further across to the west, we can see this grey outcrop line of the quartzites. You can see the very light colour. They're resting on hills of Torridonian sandstone, which in turn is resting on the Lewisian basement. This is Quinag. Let's have a look at the classic Glencoul thrust. The Moine Thrust is over there in the background, and in the foreground we have this red line is the Glencoul thrust. So moving back to the Ben More area, across Inch-to-Damp field centre, some of the limestone hills here. I've been particularly interested in this area because I did my field mapping here when I was at university. What we can see on Ben More itself is a more or less normal sequence of Lewisian, Torridonian, and then quartzite. This was actually near here, a place where I did my field mapping along the Glen Oikel area back in 1973-74 with considerably variable weather. But I did have the advantage of some aerial photographs and some more detailed 1 in 10,000 scale maps. Looking specifically now at some localities, this is Ben More, where we have the Ben More Thrust is in the middle of the window and it's fairly steeply inclined. Let's just superimpose the geology on top of that. We have sheared Lewisian, then sort of normal Lewisian, Torridonians deposited on top of that with a sort of quite an undulating surface. And then there's a smooth conformity with the basal quartzite on top of that. All of this is thrust over the top of limestone and quartzites, which are highly faulted over in the west. But as we come south, it gets more complicated, because this pink line shows the place where the Lewisian is on top of the Torridonian. And it's partly a thrust contact and it's partly an overturned contact. So the Torridonian is actually folded over here. And as it became increasingly folded, that overturned limb turned into a thrust. And I called this the auricle thrust. The more well-known Benmore thrust is this black line that comes towards the south here, and then remarkably curves around to the west. And this is because it's following the line of weakness at the top of the quartzites. To the north of this, there's a sort of dome of quartzite where the quartzites are repeated and causes a thickening and a dome. And the Benmore thrust actually goes over the top of that. You can see that here in the grey shading, and we can actually contour that, showing that the surface is curving over the top and actually outcrops again to the west. This is a very well-known feature called a clippan, where we have again older rocks on top of younger rocks, and it's gone over the quartzite and actually starts to rest on the limestone of the foreland here. Just put some labels on. That's the Benmore thrust. Benmore thrust over here. This area in the foreground around the one areas is of particular interest. The relationships of the rocks here are difficult to understand, difficult to get a grip on in the field. What we have is Lewisian and Torridonian in several patches. The advantage of looking at it like this is we can see things from views that would not be possible in the field. For example, we can move around and have a look at this little cliff here. Zoom right in. In the foreground, we've got the greyish quartzites, then we've got the Benmore thrust. And on top of the Benmore thrust, we have some Lewisian and Torridonian in rather a complex relationship, which I never quite got my head around when I was actually mapping this in the field. But from this type of view, we can actually do a little bit of suggested mapping by drawing some lines on. And this will assist us in trying to understand the relationships of the rocks here. You know, for example, this outcrop over here, how is that connected here? There's a sort of, if you're actually out in the field, you'd probably be just getting a bit lost in this peat bog, especially if it's a misty day and with horizontal rain, which it may be in northwest Scotland. So these white lines can be viewed on the internet, and then they can be downloaded back into your mapping package or into a 3D model to improve the 3D geometry of the model of the area, and try and explain, for example, how far has this thrust actually moved? Has it moved north-south, or is it just east-west? How many slices of Lewisian were caught up? You know, what was the topography of the Torridonian surface before it was involved in the thrusting? All these sort of questions can be investigated in a bit more detail with the assistance of putting the geology onto the terrain. So just zooming back out again, just as a reminder. So I hope you found that interesting. I think I've shown that using the detailed topography we can see views that are not possible from the ground. We can add some digital data, and we can improve our understanding of the structural relationships of the different rocks. Of course, it's always good to go out into the field, and I'm looking forward to being able to do that in due course, make some more measurements. And then the next step is to make a 3D model of these structures. So that's all for now. Have a good day.